1987. So STD is the IEEE's abbreviation for standard. The standards number is 1076. The number following the hyphen is the date that the standard was issued or received. VHDL was originally developed as a language for describing the digital system for the purpose of documentation and simulation, but not for synthesis. In 1999, the IEEE issued IEEE Standard 1076.6.1999. IEEE Standard for VHDL Register Transfer Level, that is RTL synthesis. This standard described a subset of IEEE STD 1076 suitable for RTL synthesis. It also described the syntax and the semantic of this subset with regard to synthesis. The latest version of this standard was issued in 2008, that is IEEE 1076 to 2008. VHDL for specification, simulation, and synthesis. Some VHDL constructs are not synthesizable. Therefore, it is possible to write the VHDL description that can be simulated but not synthesized. Okay. VHDL for simulation. The document that defines the precise syntax and the simulation semantics of VHDL is the IEEE standard. VHDL language reference manual L or M. So revised version of the standard are dated. So the revised revisions of the standards are dated 1993, 2000, 2002, and 2008. So text benches are written to apply simulates to a UAT and to verify the UAT output values during simulation. The text benches are not synthesized. Accordingly, there are no constraints on which VHDL constructs we can use in the test bench. So they should be capable of being simulated on any IEEE standard 1076 to 1993 or later complete VHDL simulator. Government developed and commercially developed VHDL with Verilog, ADA based. This one C based, strongly typecast, middle typecast, difficult to learn, easy to learn, most powerful, low powerful. So VHDL features of VHDL and Verilog. So technology are vendor independent, portable, reusable, or reusable. VHDL or PLD design methodology and design automation tools. So this is the design flow of VHDL or PLD. So first analyze the requirements, then develop specification, then VHDL, write VHDL design description, compile design description, develop verification plan, write VHDL dispatch, compile dispatch, then functional simulation, Then how to select the PLD, that is select PLD, then synthetic synthesize logic, then post synthesis simulation, then place and route logic to PLD, time simulation, programmable PLD, and verify PLD's operation. These are the design flow of VGSDL or PLD connections. So very large scale VHDL to describe both system be designed and the display used to variety of design. A software simulator tool to make mistakes during the design to verify its functionality and timing. A software synthesis tool to create the logical described by the VHDL program. The software plays and pick and place robot pick and place a place and route tool to map the synchronized logical to the logical PLD and to generate a timing control and a configuration table. A PLD to physically implement the design information in the configuration file to program the PLD. Requirement and the specifications. A very brief requirements, definitions and specification for a half adder. Servers, very simple examples of those two phases. A natural language requirement definition for half adder might be we need to be able to add two 1-bit binary numbers. From these requirements definition, we can write a natural language verification. The circuit must add two binary inputs, producing two outputs. One output is the sum from the addition, and the other is the carry. Other is the carry. A timing constraint that requires the addition to be completed in a specified time might be included in the specification. A block diagram that shows the half adder's input and output might also be included. So this is the data flow style half adder description. That is library IEEE. Use IEEE standard logic 1164.all. Entity half adder is port A, B as considered as a input logic. Some carry, that is the output, then out define the standard logic. That is end of half adder. Architecture data flow of half adder is begin sum less than or is equal to A XOR B, carry out less than or is equal to A and B. So finally end data flow. Signal assignment statement placed in the statement part of an architecture is a concurrent statement. Library IEEE program. The simplest VHDL design description consists of a single design entity. A single design entity can replace, represent all or a portion of your design. A density entity has well-defined input and output and performing a well-defined function. A design entity consists of two parts, an entity declaration and architecture body. These two parts can be placed in the same file or they can be placed in the separate file. Type STD logic provides 9 different values to represent your logic signal. This allows a more detailed representation of the logic signal state than does type bit. Both types include the values 0 and 1. Type STD underscore logic discussed in detail later. Now we will only be using the zeros and ones value from the standard logic for 9 possible values. So it is a bit versus STD logic. Bit type can be only you have a trouble of 0 or 1. But STD logic having the 9 values U, 0, 1, etc.